All right. Let's get rolling. Shut up. Did you check out any of the artwork in the hallway yet? Yeah, it's right. Yeah, those, but the really cool ones are going to be on the other side of this wall when they come in. They should come in next week. And they're like giant, but I have a bunch of at least placeholders. There's several kind of edgy ones towards the end by this painter called Michael Goddard. All right, so let's see. Homework for today was what? Do something with some strings and reverse them, crap like that. Okay. So let's look at that real quick, and then let's so maybe we'll say hello, we'll say elephant. And I said you could do all this in main, or you can write a function. So we'll do it in main first, and then we'll throw it into a function, and then we'll move on. All right, so first thing you're supposed to do is you're supposed to reverse these guys. So we'll create a string s reverse, let's say. We'll start that guy off as the empty string. We'll say for int I is equal to 0. I is less than s dot length. So that's the length of the string s, which in this case will be 5. I plus plus. Now, this would go forward. You could do the math to make it go in reverse, or we could start it at s dot length minus 1, keep going as long as I is greater than or equal to 0. And then what we can do is we can say s reversed is equal to s reversed concatenated with s dot char at I. Something like that. All right. It would be I minus minus in this case, since I'm going backwards. And then I can copy the same thing for the other. So we'll say string s2 reversed is equal to that. This will be s2 length. This will be s2 reversed, s2 reversed, s2 dot char at. And then we'll do something like system dot out dot println. What did I say? To put them together with a space, reverse, concatenate with a space, concatenated with s2 reversed. And if you didn't like the string thing, you could do that. Yeah. Reverse. Yep. All right. So there's our strings reversed with a space in between, whatever. Go ahead. No, you could have done this in C++. Yeah, we're building up another string. Yeah, well, this is all inside of a single thing, and we're not relying on it outside of here. So I think what you're talking about is, will the memory disappear? Yeah. Well, all of these variables, they'll all disappear at the end of main, but the program's also over. No, it won't end at the end of the loops. I will be. I is going to be gone at the end of this loop. That's why I was able to use it a second time. So I is a local variable to this for loop. Yeah, because I defined it inside here, it's not usable outside there. It's as if it never existed. Yeah, and this is the same behavior as we would have had in C++. All right, so now if you want to clean this up a little bit, we wanted to write this as a function. For right now, I'm just going to write it as a static function. When we get into our dungeon crawler, I'll differentiate between those two. I'll go ahead and just write a function here called static. Let's have it return a string. We'll call this guy reverse string, and he'll take a string as a parameter. Ay, ay, ay. All right, and we'll go ahead and give ourselves an empty string there. Actually, we can steal this first for loop because of the way I've named this. All right, so now this function reverse string takes in some string. What's the length of how many characters are in S? That's that length number of characters. That's the way we can find out how many characters are in this generic string that somebody's going to pass to this. So we'll create a placeholder to store a reverse thing. We'll walk S from its last legal bucket to its first legal bucket, tack on each character onto S reversed. In the end, we'll go ahead and return S reversed like that. So now we have this function called reverse string. So up here, I can say reverse string S. I can say reverse string S2. I can take out both of these for loops from here. So now main is just going to rely on our function being called two separate times, passing it two different strings, getting the reverse version, blah, blah, blah. Good.
What's the difference between putting public before the static string?
Nothing right now. Yeah, public static protected. I'm gonna teach that through use when we're doing our dungeon crawler. But the short answer to that is public is accessible anywhere inside your package. Private is only accessible inside the current class you're in. Protected has to do with inheritance. Same question. Anything else? Go ahead. Oh, this guy here? Yeah, you could. So he's saying, why even waste the time for the extra variables when you can just do that? I'll just do it again and change the variable name. S2. You can do that. You don't need to store those. We're only using them one time in our current example. So we could just get the result of those. Now, even though we're seeing this work right now, I'm going to give us an initial definition of that static keyword. Because it's an important thing for reading the documentation and also for writing code. Even though this works, I would never write it this way. I would always type it as main dot. Main dot. All right. And let me, through a slide, explain to you why. Okay, I can give you a single slide that will work every single time. And it only has to do with you looking at that single word static. If static is there, you call that thing one way. If static is not there, you call it the other way. And it's super important, and it's not very hard, but people have trouble wrapping their minds around it. And as soon as you get this straight in your head, you can read the entire documentation simply. All right. So let's get that into this dude. What am I doing? Oh man, isn't it nice having like not a zillion extra slides?
Are you going to use this for the next?
I'll just start from scratch. Well, because I go in all sorts of different directions. Like I just whatever pops into my mind each class is what we do. It's a problem. Just wait until I've already lost a step, but wait till I get like real senile. I'm like 70 years old. It's like, okay, let's talk about making lasagna. All right. We're going to call this static versus non-static. Okay. We have two different situations here. One is when we're calling methods. The other one is when we're writing methods. Okay. So when writing a method, we put static in front of methods that we intend to be owned by the class itself rather than individual instances of the class. All right. So for example, string has a method called length. We would like to be able to say s.length and s2.length and have that length method return for us the length of the actual instance associated with the string that called it, right? So that means that the length method inside string would not be static. It is owned by instances of the class. Each instance of the string class gets its own copy of that length method. And S's length method knows how many characters are in S. S2's length method knows how many characters are in S2, so on and so forth. All right. So when we have multiple copies of something that need to have individualized knowledge of it, we would make that non-static. And we'll see that through lots of examples. Okay. So in this case, we would put static in front of it when we don't have a situation like that. Maybe when we have a factory. So we might have a factory where we say, okay, your whole job in the world is if I throw a character at you, you give me back that character in uppercase. That thing doesn't, you don't call it with a character. You don't see it like C.2 uppercase or something like that. I mean, you could write it that way, but instead, it's almost like you go out and buy a toaster. And this toaster exists one time, and he has an uppercase button on it. All right. This is the static method. All right. Okay. You have the toaster with the uppercase button in it. You drop in a char. You have to provide it some information. That's the data you want it to operate on. So you drop in the char, you push the 2 uppercase button, it spits it out in uppercase. Then you drop in a completely separate char into that exact same toaster. Push the button, it spits out that different guy in uppercase. Okay. When we want that method to exist one time, and it just acts as kind of a factory that operates in other values, then something like this could work. That's kind of what we've done here. Even though we kind of had to put static in front of it in this case, and that'll make more sense later on, I made my reverse string function a static function. Static means I want it to exist once. So this guy is kind of like that toaster I just referred to. Okay. He sits on the table and I can drop any string into it. He doesn't know about strings to begin with. He doesn't know about a specific string in his initial existence. When I buy that toaster, I sit it on the desk. There's no toast in it, right? Okay. He's ready to do his job, but he has no data to work on. So now whenever I drop a string into reverse string, it spits it out in reverse. And I can drop any string I want into there and it'll spit it out in reverse. So this is kind of like a reverse string factory. And that's why it's a static method. I want it to exist once, and typically static methods will take parameters. Because you need to give it, I mean, likely the method exists because you want to perform some kind of logic. And chances are you're probably going to be operating on at least one piece of data, right? So you got to provide it that data in order for it to work. The real life example of this, keeping with our toaster analogy, is you can buy a toaster that you can put any piece of bread into it and it toasts it. That would be a static toaster. Or maybe in some sort of future world, when you pull a piece of bread out of the bag, you can hold on to it and say, toast yourself. And it becomes toasted. That would be an instance method of bread for self-toasting, where each individual piece of bread would know how to toast itself, which would be pretty creepy, right? Okay, because then you get this whole thing of, talking to your food. Maybe that would be a match. for you with the. It's like, it's like, I've invented a language for talking to all food. And I can throw this card and it floats. All right. So when we're writing methods, we put static in front if we intend it to be owned by the class itself, rather than an individual instance of the class. And I'm just going to say this method will behave like a factory that will operate on the data we hand it when it is used / called. Okay, we refrain from putting static in front of methods that we intend to be owned by individual instances of a class, where those methods already know about some data, that is, the data associated with that instance, and may be able to do its job without passing it additional parameters. So like s.length. If I have 10 different strings I've defined, I can ask each of those individual strings to report its length. That's like the toast telling the toast to toast itself, which would be way cooler than strings doing that. So this method will behave like individual. Why am I having such a problem with that? Individual. That's still not right. I got two V's. Look at that. Just do that one. Nailed it. All right. This method will behave like individual talents of each instance of that object. All right. Now, this whole slide is about static versus non-static when we're actually writing those methods, not when we're calling them. We've talked about the kind of the mentality we might have when calling them. All right. But this has to do with when we're writing them, when do we put static in the front versus when don't we put static in the front? All right, makes sense? The next slide is going to talk about if you have a static method versus a non-static method, how do you call it? All right, and that's the piece that opens up the documentation for you, because you were not involved in the writing of all those functions in the string class, for example. Somebody at Sun Microsystems wrote those, and now they've given you the documentation, so you need to call them the way they intended to be called. So now you need to be able to look at static versus non-static and know, okay, how do I use this guy? How do I use this tool? All right, I'm going to steal that thing. I screw up. When calling a method, if a method is a static, well, yeah, let's say it's a static method, it has the word static before the method definition. It is owned by the class, and therefore we must call it using the name of the class in which the method was defined. Reverse string has static in front of it. It's inside of a class called main. I call it by saying main dot reverse string. Make sense? Now you might ask, well, didn't it work without putting main in front of it before? Yes, but don't let that go to your head. It worked in this very specific case, but it will not always work this way. This is kind of like those curly braces for if statements and stuff. It's never going to be wrong to put the name of the class in front of the method. Okay. Does anyone know why reverse string will work without main in front of it here? Go ahead.
Well, I'm not 100% sure. Yes. Would it be because Java would just figure it out because it's in main?
No. Reasonable guess, because Java does do some magical stuff. You have a guess?
I mean, kind of similar, it just sees that, it's called it in the main file, so it'll just use it because it's gonna look in the main file.
Okay. So again, kind of Java doing magic behind the scenes. No. Anybody else? I know we have a couple of Java programmers in here. And see, this is kind of that danger. Who's calling me? It's calling my office phone because now our office phones are all in Zoom. Go ahead.
Why does main work in the first place? Like, wouldn't it, like, shouldn't it be like doing this and shouldn't it be like this instead?
No, but I mean, it's the same way as C++. We didn't have this and stuff inside of main. Main works, and that maybe falls into more of that magical thing. All programs begin and end with main. That's true in C, C++, Java, C#. You start getting into Android stuff, you dig, cut enough layers down, you find main. It's there. So we maybe can call that main part of the magic of programming. It has to know where to start the program. So when you run it, it's just decided main is where everything begins, and we're going to keep that consistent across. Let's call it most languages. I'm sure there's some language that doesn't use main, but yeah, so that's probably more in the implementation of the language they just chose to make Java start looking in this function called main. All right, any other suggestions on why this would work? This is a super important lesson because this comes down to, and I mentioned this last semester as well. Just because something works doesn't mean you should use it if you don't understand why it works, right? Go ahead.
This seems to be writing it exists, and
so you're saying when I say reverse string here, it's just, it assumes that it's going to exist somewhere, and then when it finds it somewhere, it's going to, yeah, that's how it works. It has to do with something called a context. Main is a static method in Java. So since it's a static method inside of the main class, if we pretend like this is like a, you're inside of like a, I don't know, airtight bubble, okay? Everything that's inside this bubble is happening inside of a static context inside of the main class. Which means that because you're in a static context, you have access to other static members of that same class. So the only reason this works here is because this function happens to be static inside of the same class as this static function is written in. If this function was not coming from a static context, and this is where it gets weird with your compilers, potentially it might make a magical connection by rewriting the compiled code under the hood to call it using the name of the class. That would be a similar argument to never using default variable values. Like you define an integer a, and you don't give it a value and just assume, well, it's probably going to start at a 0. Java will scream at you in that case saying you may not have initialized this, where some older language will just say, hey, you probably know what you're doing, and just let you go with it. All right, so this is called a context. So while we are inside of this reverse string method, we are living in a static context of the main class. While we're in the main method, which is a static method, we're living in a static context of the main class, and therefore we have access to the other static stuff inside of main. Having said that, if we follow this rule of if it's a static method, we call it using the name of the class in which that method was defined. That will never be wrong. This will work when we're in main, like right now, even though we've kind of just discussed that it's actually not required in this case. But this will also work if we're in a completely different file that happens to have access to this class called main. Now you can call static methods of main by just saying main dot from a whole different file. So the way you can always call static members of a class is by using the name of the class in which that method was defined. So since this has the word static out front, that's the only thing that makes this guy static. Forget about why they made it static, why we made it static in this case. The fact is we did, for whatever reason, hopefully a decent one. But the fact that it has the word static in front of it says this guy is a static method, and therefore if you want to call it, you call it using the name of the class in which that method was defined. This method is defined right here inside of a class called main, so we call it by saying main.reverseString. Go ahead.
Kind of like exclusive group, like each function says that they're in the group, and all those functions can use stuff that the other functions have, and they can also use stuff that's not static, but the other functions that aren't static can use stuff that's inside of it. But that really, in a sense, is that not a whole.
Yeah, I mean, I think that starts trying to add some weird stuff into it. I mean, really, it comes down to how many times do we want this function to exist? We put static in front of it if we want it to exist one time ever, and we'll just, that's that factory idea. If we want it to exist one time ever, and we'll just throw at it the data we want it to work on, we make it static. If we want it to exist for every instance of a class, where that doesn't make a lot of sense here because we would likely never make an instance of main, this class main, because this is kind of where, this is like the quarterback of our program. All programs begin and end with main. So typically most programs, your entire main class is going to end right here. We won't have extra crap inside of main unless it's just little functional things that you might need for the specific problem. But typically in object-oriented programs, main is going to be very simple. Program starts there, it creates an instance of the dungeon, an instance of the player, throws the player into creates an instance of the dungeon and tells it to start. You know, that's your entire main method, or, main method inside of the main class. And it's using all the other stuff you created to run your program. All right. So typically you would never write methods, whether they're, certainly not instance methods, but even static methods inside of your class that has main in it in production type programs, because it's typically not needed. You'd usually put those things inside of the classes where they make more sense. And we'll see that as we get into our dungeon crawler. All right. So if a method is static, that means it has the word static before the method. It is owned by the class, and therefore we must call it using the name of the class in which the method was defined. And we already saw this as a little bit of a blurry must, because we saw an example where you didn't have to do it that way, but I promise you it'll never be wrong if you do it that way. And if you're using a modern day IDE, a development environment, if you put the name of the class and then a dot, it'll give you a list of all the class, the static members of that class, so you don't misspell it. Other benefit. All right. I'm going to put something here. These are called class methods. You say, or members. Why don't we say class or fields if it is a field. You can have global variables, static variables of a class as well, that you could call directly. A lot of times that's when we start introducing that public-private protected stuff, and we'll see that by example. So when we get into that, I'll point that out then. All right, so if a method is not static, it does not have the word static in front of it. It is owned by individual. Oh, there's that word again. Oh, I nailed it. Boom. Man, that's almost like you with the card thingy. It is owned by individual instances of that class. So each instance gets its own copy of that method. And we call the method using an instance of the class in which that method was defined. So for example, we go into the documentation, we go to string, we go down to the length method, which we use char at too, but let's just look at length here. Here's the length method, right? It returns an int, but do we see the word static over here? We do not see static, which means it's an instance method. How do we call instance methods? Using an instance of the class in which it was defined. What class was length defined in? Class name string. So I need an instance of string, like I have right here. S is an instance of string, so I can say s dot length to call that non-static method from the string class. Make sense? As opposed to saying something like, if it was static, I would say string dot length, like that. Now that's not going to work. Why? Why do you think they wrote length as an instance method instead of a class method? Or kind of undefined. Like, what do we expect the result of this to be? If we say generic string class, tell me your length. Doesn't make any sense, right? We care about the length of individual strings. Hello, or elephant, or world, whatever it is, right? That's why they made it non-static. Because every instance of the string class really needs to have its own copy of length, so that guy can return the number of characters that are in that particular string. Make sense? I'm guessing it's probably going to scream at us. A non-static method cannot be referenced from a static context. There's that context flippy dealy. All right. I mean, but there isn't a, if we go back to the documentation here, there isn't a length method. Well, there isn't one that takes a parameter. This guy takes no parameters. It's called length, open close parentheses here. I don't need anything to work because I'm an instance method and I know about the string that's calling me. So if you tried to pass it something, even if it was a static method, it's going to scream at you and say the method that there is no method that called length that expects a parameter. So it's going to scream at you for a different reason. All right, that makes sense? All right, now let me just show you. So before we go any further here, do these couple of slides. So I'm going to say these are called instance methods or fields if it is a field. All right, these two slides make sense? Super important slides. These are top fivers. All right. This slide is about when you are writing those methods, when should you make the method static or make the method non-static? Or if you're trying to look into the psyche of the Sun Microsystems folks who wrote the string class and try to wonder, well, why did they make this guy a non-static method rather than a static method? I refer to these as instance methods pretty often. That's why I put that on that slide. as opposed to static methods. I often refer to those as class methods. Static methods are owned by the class. Non-static methods are owned by the instance, hence instance methods versus class methods. All right. So this slide's important mostly when you're writing your own methods. You decide, well, does this guy just need to exist one time? I'm just going to throw the data it should work on at it. Or does he really need to know about each individual instance? If he only needs to exist once, you put static in front of it. If he needs to work on each individual instance, you don't put static in front of it. Okay. Or you can try to look into the psyche of documentation that's already there. Like, okay, well, why did they make this static versus non-static? Because sometimes it is interesting, especially when you're dealing with third-party software. You'll be like, why did they do that? It really maybe makes more sense the other way. I mean, programmers are not perfect. You know, sometimes it's even a toss-up. Like, you know what? I mean, I could give it the data, but it probably could get the data on its own. Which do I want? Do I want to explicitly provide it the data that it needs? Or do I want to call that method and have it go and look up the data from some other place to get the data it needs? Sometimes it is a toss-up. All right, but this slide has to do with when you are writing that method. This slide is probably the more important one. First of all, it's going to tell you how to call the code that you wrote, right? If you wrote it with static or not static in front of it, this tells you how to call it. But more importantly, this slide right here opens up the entire documentation. So you look at strings here, most of the string methods are instance methods. So we call them with instances of the string. We get down near the bottom here, we have a couple of things like a static method that returns a string called value of, that I pass it a value. This is kind of like a factory. So we have this string factory that I can throw a Boolean at, and it spits out the string version of that Boolean. That's our toaster. That's the string toaster right there, right? Okay, I can throw it a, this is kind of a weird one. You know, I can throw it a character array, as well as how far into that array I want it to start, as well as the number of characters I want it to grab. So I can maybe say, you know, here's this 200 bucket character array. I want you to start at bucket 5, and I want you to give me the next 15 characters. And it'll throw those back to you as a string, in case that was useful to you. All right. But these are all static because they're like factory methods. You know, these are kitchen appliances. All right. Now, a more practical example of class methods. If I go to the character class, I think I mentioned before in Java, you know, we have all the kind of the same primitive types that we had in C++, and primitive types, they're built into the language, and they can only hold a value. That's their entire base talent. But now we have this class called character, and most of the methods in here are static methods. Well, these are static fields here. Let's get down to the methods. So these are static methods. Let's see. Oh, this is an interesting one. So I can say character. So it's static. I call it using the name of the class in which it was defined. It's a class method, right? So I would say character dot digit, and I can pass it a char, okay? Maybe like an A, and a radix, like a 16, and it would return to me a 10. For example, that converts from hexadecimal back to decimal. Okay, so character dot digit, passing it an A, passing it a 16. I'm saying, here is the character that I have. I happen to know this guy's in base 16. What decimal number is that dude actually? It'll spit out the 10 for you. You gave it an F and a 16, it'll give you a 15. Make sense? We wrote this code last semester using them. You know, we wrote a couple of functions that does the same thing. I mean, this doesn't, you know, life-changing stuff, but it's a feature in there. More common things might be like 2 uppercase. Or these are some good ones. Here's like a is lowercase. So we can ask if this particular character is a lowercase character. It'll return true or false. We might be interested in that, right? So you're writing your program. So we have this factory called character. that I can throw chars at and say, do various operations on this dude and give me some information back, because they're like, hey, look, is this char lowercase? Yes or no? It figures out whatever that means. You know, could we rate it ourselves? Sure. We probably have to say, is this guy between these two Unicode values, right? You know, we could do it because we know how chars are stored in C++. They were stored as 8-bit ASCII values. In Java, we expand our character set a little bit bigger. It uses Unicode. So it's a 16-bit Unicode value. There's 65,536 unique characters in Unicode versus 256 in ASCII. That's the difference between 2 to the 8th unsigned and 2 to the 16th unsigned, because there are more languages in the world than English. That's where Unicode comes in. So we could write it ourselves. You know, this is not doing something we could not write on our own, but sometimes these are nice conveniences that are built into the language that we might just want to use. So if we have chars and we want to do something to a char, maybe the first place we look at is the character class and say, hey, does this guy have a class method in there that might do what I need it to do before I go and write it myself? All right. And why do you think all the methods in the character class are class methods? If we're trying to look into the psyche of the Sun Microsystems people, why are these guys class methods versus instance methods? Jeopardy music playing. When we, for instance, pun intended, when we're working with strings, we saw that most of the methods inside the string class are instance methods. And we do something like string s equals hello, right? We create instances of strings. And we expect that string to be able to do stuff to itself, report its length, give us the character at a certain spot, things like that. Now, when I create a char C is equal to the character A, for example. Same syntax as we had in C++, right? Nothing new here. C is a primitive type. Primitive types are built into the language. This guy only knows how to hold this value. He doesn't know how to do any of these other magic tricks. He's not an object type. So we ask ourselves, might we want to do things to chars? Yeah, we might be interested if that guy's upper or lowercase. We might be interested in converting him to uppercase. We might be interested in all sorts of stuff, right? Now, Sun Microsystems, they said when they wrote Java, like, okay, we're going to go ahead and give you a class for doing things to chars. But they went ahead and filled it up with a bunch of static methods. Why? Because the character class does not need to hold a char. It actually technically is capable of doing it, but it's not common to use the character class that way. It effectively is that toaster, because you already have a way of holding chars in Java. It's through the char primitive type. We can store chars simply. That came from our great-great-granddaddy C, right? But we didn't have a way of operating on those chars because primitive types can't do it themselves. So the Sun Microsystems people said, okay, here's a whole bunch of class methods that let you do things to those chars that you already know how to store. Make sense? That's why they're static. We're not operating on an instance. We already know how to store them. So the thing that would have been our instance over here, in my case here, is this character C. That guy, let's say, would have been our instance. It's not an instance because instances are instantiations of a class, and this dude predates objects. It's not an instance of a class. That dude's just a variable. That's all he is. It's a one-hit wonder. He can hold a value. That's it. So we have this factory that we can throw chars at, and it gives us some information back. And do you think there's a very similar factory for every single one of our primitive types? Integers, doubles, floats, yada, 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 yada. You just glance at the documentation here. You know, here you got byte, you got Boolean, you got character, you got double, you got float, you got integer, you got long. You can even do things with generic objects, but that's also built into the language. Shorts, the whole shebang, Make some sense? That's the logic why character class has a bunch of static methods, class methods in it. String class has a bunch of instance methods in it. Strings are objects. We can build a string that holds a value, but strings can do more than just hold a value. They can also perform operations on themselves, like report their length, that kind of stuff. All right. Questions, comments, concerns about that? So both of these slides are super important, but this one, this slide right here, opens up the entire Java documentation to you. Go to any class in there, just pick a random class. Let's go to all classes here. We'll just pick a random class here. Atomic long. Let's see what this dude is. All right, here's its method summary. Class method or instance method? Instance method, how do you know? No static. Let's see, where all these guys were instance methods. Here, let's pick another guy here. Whew, give it like a big wheel of fortune spin. Here, composite view. Oh, this is from the user interface stuff. All right. So yeah, all instance, right? You see a couple of new things in there, like the protected stuff. We've mentioned that, but yeah, those are all instance methods as well. Oh, here, how about manifest? Is that going to give us anything good? Man, this guy's screwing us. So far, it's proving you pretty much just guess it might be an instance method, right? Killing me. I promise you there's plenty of class methods in Java. Some of these are. Oh, there we go. You long sequence helper. I mean, I have no idea what that dude's for. Let's see, what is it? The helper for you on for. Oh, you got to go find out what a ulong sequence is first. This guy helps with those. whatever a ulong sequence is, he helps it. All right.
Separate class. Just
Yeah.
know.
But that's kind of like our factory, right? The character class exists to help us with chars. This guy exists to help with ulong sequences. Super important. Go ahead.
Just to clarify, the string is not a primitive type.
Correct.
Okay.
Strings are object types, but they are special in Java. They behave a lot like primitive types, but they are objects. All right, questions, comments, concerns, bribes. We will start writing dungeon code next class, now that we know about instance versus class.
Kind of like